Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over how to multiply polynomial expressions. Alright, let's take a look at the first example. Question number 1. We're to find the product. We're going to be finding the product of these two polynomial expressions, x plus 5 multiplied by x squared minus 3x plus 2. Okay, so in this case, we have a linear binomial being multiplied by a quadratic trinomial. I want to show you a method that can be used to really facilitate the multiplication of polynomials when you have two or more terms being multiplied by three or more terms. Okay, I'm going to be using something called the box method. Alright, so let's go ahead and make use of the box method. What I'll do is I'll take the second polynomial expression, the one with three terms, the quadratic trinomial. Let me put that on the top of the box. We have x squared minus 3x plus 2. The terms of this quadratic trinomial will basically determine the columns of my box. Since I have three terms, I'm going to have three columns on my box, okay? And then we have a binomial, a linear binomial that we're multiplying by, that will go on the left side of the box. We have two terms. These will determine the number of rows that I'll have. So x and then plus 5. Now what we are creating is basically a multiplication chart. Alright, just like your typical old-fashioned multiplication chart that you learned how to use in elementary school, that's what we're creating here. But rather than just multiplying numbers, we're going to be multiplying variables also. Okay? Now before we start multiplying, I would like to refresh your memory concerning a property of exponents that we are going to be using. Okay? And that is basically the product property of exponents. So what happens when you multiply two exponents of the same base? So you have x to the m times x to the n. What is the result here? Using the product property of exponents, all you simply do is add the powers, x to the m plus n. Alright, I'll be using this formula when I'm multiplying my polynomial terms, okay? So keep that in mind. Okay, let's start multiplying. So we will have to start out by multiplying x and x squared. Remember, x has a power of 1. You don't have to write it there, but it's there. So when you multiply x and x squared, you add the powers and you end up with x to the third power. Okay? If you do not want to use the shortcut, you can write it out and just multiply, count the number of x's you're multiplying, and that will give you the correct result. Now, moving along to the second column on the first row, x to the first times 3x is negative 3x to the second power. There's a 1 here, and you just add the two powers, and you have x squared. Now, last column, times x, x to the first power times 2, that just gives us 2x. Alright, let's move on to the second row. We're going to be multiplying 5 by these three terms here. 5 times x squared is 5x squared. 5 times negative 3x plus times minus is negative. 5 times 3 is 15. And we have x to the first power. It's as though there's an x to the 0th power here, and if you add 0 to 1, you just end up with 1. The last entry involves multiplying our two constants. 5 times 2 is 10. Okay, so now to finish things off, we're just going to combine like terms. The nice thing about this method of multiplying polynomials is if you have a lot of terms, the box helps you organize your terms. So you don't have your terms all over the place and you have difficulty combining like terms. It's neatly organized for you here. Okay? Now, x to the third does not have any other like term to be combined with, so we'll just simply bring that down. X to the third Now, if you notice, these two terms on this diagonal are like terms. They're both second degree um, variables in the variable x. Okay, so you have 5x squared minus 3x squared. Those are like terms. We'll just combine the coefficients. Okay, so 5 minus 3 is 2, so plus 2x squared. If you take a look at the next diagonal, we have two like terms nicely organized for you again. So we just simply combine them along this diagonal. These are two first degree terms in terms of x. So we just combine the coefficients and add on the x to the first power. So what is negative 15 plus 2? Signs are different, subtract, and keep the sign of the bigger. So you have negative 13x. And the constant stands alone. It doesn't have any other constants to be combined with. So we just drop down 10 plus 10. Okay, so this is our final answer, the product of the linear binomial x plus 5 and the quadratic trinomial x squared minus 10x plus 3. Alright, now let's take a look at another example. In this case, number 2, we are to expand the linear binomial x plus y. X plus y raised to the fifth power. Actually, this is not a polynomial. So you have x plus y raised to the fifth power. So the method I'm going to be using is the Pascal's triangle. You can do this by writing down 5 x plus y's and then distributing them 2 at a time. That will take you a long time and it's very inefficient, and the odds of making errors is pretty high. Okay, so the best way to expand binomials of higher degrees is to use Pascal's triangle. So let's go ahead and set up Pascal's triangle. Okay, so what we're going to do is we're going to set up Pascal's triangle all the way to the fifth row. The reason why we're going to the fifth row is because this binomial is being raised to the fifth degree. Now, one thing you want to remember concerning the setup of Pascal's triangle is that you always start from row 0. Okay, so this is row 0. And then we're going to set it up. We have 1, 1. You always have 1s at the ends. The first row has no number in the middle because you have only one number on the top and none on the sides. Okay? Imagine as though there were 0 and 0 over here, and then when you combine them, you get nothing. Now let's advance to row number 2. You start out with 1s at the ends, and then you add these two numbers on the top to get the bottom middle. 1 plus 1 is 2. That's row 2. Keep on going. Row 3, put the 1 and the 1 at the ends. The number at the bottom of 1 and 2 between them is 1 plus 2, which is 3. And then 1 plus 2 yields 3 for the second number here between 2 and 1 at the bottom. Okay? Row 4, 1, 3 plus 1, 4, 3 plus 3, 6, 3 plus 1, 4, and 1. One more row, starting out with 1s, 1, 1 plus 4, 5, 4 plus 6, 10, 6 plus 4, 10, 4 plus 1, 5, and then you have a 1 at the right end. Now what we're going to do is we're going to extract row number 5 to help us determine the coefficients of each term in the expansion of the binomial x plus y. Okay, so let's extract that entire row. We're going to have 1, 5, 10, 10, 5, and then 1. Okay, now let's go ahead and expand it. We're going to now take these two terms and place them in the parentheses. We have x and positive y, x and y, x and y, So basically, I'm taking x and y and writing their product next to each of the values, each of the numbers I got from the fifth row of Pascal's triangle. Okay? So just orient them like this. You take the terms and their signs. Okay? Now we're going to assign degree values to each of these variables in the parentheses. Now x will start with the highest power, which is 5, and y will start with the lowest power, which is 0. Okay? What is going to happen is that the powers of x will descend from 5 all the way to 0, and the power of y will ascend from 0 all the way to 5. It's as though we have a power switch happening. So let's start with x to the fifth. We're going to descend all the way down to 0. So 5, 4, 3, 2, 1, 0. Okay? And then with the y's, it's going to ascend from 0 all the way to 5. So we have 0, 1, 2, 3, 4, 5. Now, if you examine these variables with their powers, one thing you will note is that the powers always add up to 5. So 5 plus 0, 4 plus 1, 3 plus 2, 2 plus 3, 1 plus 4, and 0 plus 5. The powers have to always add up to the power of the power that you're raising the binomial to. Okay? So now we're going to simplify. The terms raised to the 0th power, those are going to be 1, so that will be 1. This one right here will be 1. So it will not be considered in the determination of the product. Now after eliminating those two terms, they are 1's, we are now going to simply multiply. Okay, let's start with the first one. We are going to have 1 times x to the fifth. 1 times x to the fifth is simply x to the fifth. Moving on to the second row, 5 x to the fourth y. The third row, we have 10 x to the third y square. The fourth row, we have 10x squared y to the third. In the fifth row, we have 5x y to the fourth. And in the last row, we simply have 1y to the fifth. Okay? So if we find the sum of these products, that will be the expanded form of x plus y to the fifth. Let's go ahead and write it down. It's going to be x to the fifth plus 5x to the fourth y plus 10x to the third y squared plus 10x squared y to the third plus 5xy to the fourth plus y to the fifth. Okay? So this is basically a quick and efficient way to multiply binomials of higher powers. Okay? So that's that. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your study of polynomials, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions about the material we covered in this presentation, just feel free to post your questions in the comment section below, and we'll be more than glad to offer you support. More clips can be found on mathgotserved.com, and also do not forget to subscribe for our updates. Thanks again for watching, and have a wonderful day. Goodbye.